Ever wonder how we literally bottle lightning? Let's dive into this explainer and unlock the power of electrochemistry.
By forcing electrons to move, we actually rip compounds apart. It's how we store incredible amounts of energy.
To pull this off, we use two highly polarized gateways, the positive anode and the negative cathode.
Both sit totally submerged in an electrolyte. That's a conductive liquid ready for a massive chemical transformation.
It's a microscopic dance, right? Electrons sprint through the wire while ions physically swim through the liquid. Imagine zooming deep into molten lead bromide. It's this extreme environment where chemistry becomes completely visible.
Lead pools up as a silvery liquid metal, while bromide furiously bubbles off as a brown gas.
But the second you add water to the mix, the rules of this chemical game totally change.
With salt water, we suddenly get toxic chlorine gas and explosive hydrogen, leaving behind some really harsh lye.
Swap that for dilute acid and the water gets cleanly ripped into colorless oxygen and hydrogen bubbles.
The secret here? Concentration. A crowded solution yields halogens, but a watered-down one cranks out pure oxygen.
Now watch the physics change when we swap in active copper electrodes instead of inert ones.
It basically becomes a literal teleporter. It dissolves copper on one side and beautifully plates the other.
So, how do we harness this atomic teleportation to actually build things in our everyday lives?
Through electroplating. We literally armor cheap metals with a shiny, corrosion-resistant skin of pure gold or chrome. Behind the scenes, this is a redox reaction. It's a microscopic, never-ending tug-of-war for electrons. Oxidation means losing those electrons, while reduction is capturing them to totally transform the atom.
But get this, what if we run this entire process in reverse to actually generate power?
Enter fuel cells. By reuniting hydrogen and oxygen, they generate clean electricity, exhaling only pure water. They're incredibly green, for sure, but taming and storing hydrogen gas remains a really expensive engineering puzzle.
So, is the key to our entirely green energy future already hiding inside these basic chemical bonds?